Find the arc length of the space curve given by r of t equals t cosine t, t sine t, 2 root 2 over 3, t to the 3 halves, from t equals 0 to t equals 4. And then we'll continue practicing our derivatives and our integrals by doing another one. We'll find the arc length of the curve given by 3 halves t squared, t times the square root of 6, log 2t from 1 to e. So if we have a space curve parameterized by time t going from A to B, and this is a curve r of t given by position vectors, then the arc length is given by the formula integral a to b of the magnitude of r prime of t dt. So we're integrating the speed of the curve with respect to time. The speed times the time will give us the distance. So we're summing up distances over infinitesimally small time intervals to get the total length of the curve. So we have to calculate r prime of t, and then we have to take the magnitude of that, and then we need to integrate. So r prime of t in the first case, we need the product rule. So the derivative of the first is 1 times the second plus the second, the first times the derivative of the second. So t times negative sine t, so I put that plus sign there prematurely. So that's going to be minus t sine t. And then same idea for the second component, sine t, and then plus t cosine t. And for the third component, we have this strange coefficient here, but when we use the power rule, 3 halves comes down, cancels out to 2/3, and we get the square root of 2, t to the 1/2. And now we need the magnitude of this. So we have to sum the squares of the components and then take the square root. So we have to square each component, add them together. So squaring a minus b gives a squared minus 2ab, so 2t cosine t sine t, and then plus b squared is t squared sine squared t. And then plus, and do the same for the second component, a plus b squared is a squared plus 2ab, and then plus b squared t squared cosine squared t, and then square this one, we'll get a 2, and we'll get a t, so 2t. And then we have to take all of this to the 1/2. First observation is that this term here and this term here are negatives. Next, I'm seeing a cosine squared plus a sine squared, so that's 1. And then I'm seeing a t squared sine squared t and a t squared cosine squared t. If we factor out t squared from those two, we get cosine squared plus sine squared, which is 1. So this is plus t squared. And then we have 2t plus 2t to the 1/2. And this is a perfect square. We might recognize it better if I just rearrange the terms. And that's t plus 1 quantity squared, and then we have to take the positive square root of that, so that's the absolute value of t plus 1. And in this problem, t is between 0 and 4, that's our interval, and so that means that this is just equal to t plus 1. So finally, our length is the integral from 0 to 4 of t plus 1 dt, so we have a nice simple integral coming out of this. we had a very contrived function so that there would be a lot of cancellation and combination of sine squareds and cosine squareds to give us this wonderful perfect square here. And so this is t squared over 2 plus t from 0 to 4, which is 12. So the length of the curve is 12. Let's try number 2. In number 2, t is going from 1 to e, and there's r of t. Let's write that one down. R of t is 3/2 t squared, and then t times the square root of 6, and then the log of 2t. So the magnitude, so first r prime of t, and then the magnitude. R prime of t is 3t, square root of 6, and then chain rule here, we'll get 1 over 2t times 2, which is 1 over t. And then the magnitude of r prime of t is, we have to square each component. We'll get 9t squared, 6, and 1 over t squared. And then we have to take the square root. And this is also a perfect square. It's 3t plus 1 over t squared. Let's double check that. If we square 3t, we get 9t squared. If we square 1 over t, we get 1 over t squared. And then if we do the 2ab middle term, 2 times 3t times 1 over t, 2 times 3t times 1 over t is 6, because the t's cancel. So that's our that's the sum of the squares, and then we have to take this to the 1/2, the 1/2 power. And this is the absolute value of 3t plus 1 over t. T was between 1 and e. So this is positive. So this is equal to 3t plus 1 over t. So our length is the integral from 1 to e of 3t plus 1 over t dt. And that's 3t squared over 2 plus the log of the absolute value of t from 1 to e, which is 3e squared over 2 plus the natural log of e minus the sum, plugging in 1 minus 3/2 minus natural log of 1. And this is 3e squared over 2 plus 1 minus 3/2 minus 0. And 1 minus 3/2 is minus 1/2. So we have 3e squared minus 1 quantity over 2. So there's the length of our curve. And that is a positive number. We should always make sure that in our calculations, our length is a positive number.